Okay, 1.8 combinations of functions and composition of functions. We've done this before, so it's going to be a quick review. Two functions can be combined through multiplication, addition, subtraction, all that kind of fun stuff, like always. It says find the sum. You have this picture, yes? Yeah. So we are doing f plus g of x. I could also write it f of x plus g of x, correct? I can write it those two fashions. Yes?
Yes.
Okay, so you only add where their domains overlap. Got me?
Yeah.
Okay, so this is g on the bottom, f on the top. So at -2, does f exist? At -2, does f exist? No. So can we add it? No. Okay. So -1, do they both exist? Yes. Okay. What do you get? 0 plus -1 is what? -1. Ooh, yellow doesn't work good, does it? Okay, so then at 0, I've got 1.5 on f, yes? And I got -2 for g. So what is -2 plus 1/2? -1/2. Okay, at 1, g's 1 and f is 3, so 1 plus 3 is 4. Now at 2, f exists. Does g? No. Nope. So our addition of these two is that, correct? Okay, if the domain does not exist, then you cannot add them. Got me? Okay. Questions on this? Okay, and just down at the bottom, it just says it consists of all common. Okay. So you've seen these, sum, difference, product, quotient. I've just written them, the two different ways you could see them. Depends what mood I am in. You've worked with them, right? Why can't G be 0 over here? Because I can't divide by 0. But writing them any of these ways works? Doesn't matter. Am I good? Okay, I want the sum, difference, and product. You'll have several problems that say sum, difference, and product. So f of x is 2x minus 3, and g of x is x squared minus 1. So I want f plus g of x. I expect you to show your work and write what you're doing. So what I'm writing on here is what I expect to see on your paper. So 2x minus 3 plus, I don't need a parenthesis here, but I'm going to put it. Why don't I need a parenthesis when I add? I'm going to add everything. It's not going to change the sign, is it? But do I need the parenthesis when I'm going to subtract? Yes. So you might want to put it there just to keep your brain. Okay, so now what do I get when I add these two?
X squared plus 2x minus 1.
Okay, just combining like terms, right? Make sure that you are reading directions, because on a test, it probably will look like this, and every time I get people multiplying it. Is that what it says?
No.
It says what? Add. Make sure you're looking at the problem. Okay, f minus g of x. I don't have to put the first one in parentheses, but do I have to put the second one?
Yes.
Yes. So Cadence, what'd you get?
Nothing yet.
Nothing yet? Well, let me know when you do.
Negative x squared plus 2x minus 2.
You guys agree with her?
Yeah.
I do too. Okay. So, can I change this and make it g minus f and get the same answer?
No.
No, because subtraction isn't commutative. So do you need to pay attention if it wants f minus g or g minus f? Yes. Okay, so f g of x. Now we have to do what? Multiply. Now we have to distribute, right? So do that, and I'll do that. We better get the same answer.
Oh, wait, I like your shirt.
So did you get 2x cubed minus 3x squared minus 2x plus 3?
Yes.
Okay, so f divided by g is simply f divided by g. So f is 2x minus 3 divided by x squared minus 1. Now, in order to do this division, I would have to factor before I could simplify anything, yes?
Yes.
Can I factor the numerator?
No.
No. Can I factor the denominator?
Yes.
Yes. To what?
X minus 1, x minus 1.
Okay. And x can't be what?
0.
No, it can be 0 all day.
1.
Plus or minus.
Plus or minus 1. Okay, so I want to see you factor it. Even I knew that these weren't going to reduce, but we got to get in the practice of factoring them every time. Okay? So as you get further on, you may not write it out, but in your brain, you're factoring to C. Okay? So we're going to start by making sure we write it out. So we're going there. Questions? Is it all coming back to you a little bit? Okay.
The answer would be x equals plus or minus 1,
Cannot equal.
or cannot equal plus or minus 1. For that.
Give it back to me. Okay. This whole thing
Is the answer.
is your answer.
Okay.
They don't always want the excluded values, but should you always be aware of them?
Yeah.
Yes. You could write it in as a domain if you wanted to. Or excluded values, either one. Okay, given f and g, find the following. What am I doing on the first one? Dividing. So do it. We'll do it with all of them, I guess. Okay, and what do I have to do on this first one?
Factor.
Factor. So I have x minus 4 over what? Now you got to factor it. Factors of 8 that have a difference of 2.
4 and 2, maybe
So x minus 4 and
X plus 2.
x plus 2. So the x minus 4 is the whole thing. If you forget, put parentheses around it, right? The whole thing reduces to 1. So my answer is 1 over x plus 2. And x cannot equal what?
2. Plus or minus. Negative 2.
And negative 2 and
1, 0.
look at the 4 right here. Yes? Negative 2 and 4. So g divided by f. Well, I'm just going to take this and reciprocate it, right?
Why is it negative 2?
Because if you set it equal to 0, it switches signs.
Oh, yeah.
Okay? So now what's going to happen? The x minus 4 is reduced out, yes?
Yeah.
To 1. So I'm left with x plus 2, but x still cannot equal what? 4. Now, what's the last one tell me to do? What's this tell me to do? Divide and then do what? Not multiply by negative 1. Was f over g of x right? So our f over g we already know is 1 over x plus 2, yes? So now f divided by g of negative 1, it'd be 1 over negative 1 plus 2. So that would just be 1. Good?
Yeah.
Okay, composite functions. It's putting one function into another. So we can write it as f of g of x. You notice the g of x has taken the place of x, hasn't it? So you're putting that whole function. Or we can write it like this, and it's read either way, f composed of g. If it was g of f of x, it would be what? G composed of f. So you're putting the function into a function. So if f is x squared and g of x is x plus 1, f of g of x, I hate writing it that way because it looks like I'm writing fog. I prefer this method. Either way is right. I have to put this whole g every time I see x. If there's 10 x's, I have to put it in there. So it's going to be the quantity of x plus 1 what? Squared. Now remember that's x plus 1 times x plus 1, correct? So what? X squared plus 2x plus 1? Check my math, but I'm pretty sure I'm right. The biggest mistake I get here is people tell me this is x squared plus 1. Do you know how they get that? Yeah, they just square the x and the 1. Is that what's going on here? No. The square does not distribute over addition, subtraction. It distributes over multiplication, division. And this is why. Can I multiply anything regardless of what it is? If it's a variable and a number, can I always multiply them or divide them? Yes. I don't have to get like terms, do I? And so I can do that operation and then do. But can I add or subtract anything regardless of what it is? No. And if I can't add or subtract it, then I can't ever get to the exponent part of it. So that's the reason why it can't happen. Am I good? Cadence? Okay, so we have F and we have G, and we're gonna do a few. So which function goes into which on the first one? F composed of G. Layden? Which function am I putting into which function on the first one? Say it.
G into F.
G into F. Whatever's here is going into here. Okay? So I have 1x. So what is x now? 4 minus x squared. So I always put parentheses just so I know where I'm plugging it into, and then plus 2. And then combine like terms. So what would get? Negative x squared plus 6. Is that right? So now what's happening on the next one? You're putting F into G. So G starts off with 4. There's no x, so it's just 4 minus. Well, now I have x squared. So what's my x become? X plus 2. And then we got to do what with the quantity? Square it. Now, can I distribute that negative before I square it? Please tell me no. No. Because order of operations says I have to do my exponent first, right?
Yes.
So I have 4 minus. Okay, so now what do I have to do? Now distribute a negative, right? And then combine like terms. So I get negative x squared minus 4x, and then it'd be 0, wouldn't it?
Yes.
Okay. Now what's this one tell me to do? Put F into what? G, and then make X what? So it says put F into G and make X negative 2. So did we already put F into G? Yeah. And we got negative x squared minus 4x. So now I have negative 2 squared minus 4 times negative 2. Parentheses are important here because without them you would have told me that was a positive 2, correct? And is it a positive 2? No. So negative 2 times negative 2 is 4, but there's a negative on the outside, so it's negative 4, because you all would have told me that's a positive 4, wouldn't you? Ha. Plus what? 8. So my answer is 4. Now I am going to show you another way. Okay? I can put negative 2 into F, and then my answer into what? G. So if I put negative 2 into F, so I'm going to do F of negative 2. I get negative 2 plus 2, I get what? 0. And now I'm going to do F of G of F of negative 2. So it says take the answer from here and plug it into where? G. So that would be 4 minus 0 squared, which would be what? 4. Did we get the same answer?
Yes.
Yes. They will also give you a graph. I don't know. Looks like this. And they'll call this F. And they'll call this one G. And they'll say they want this. So it says go to negative 2, find your Y, correct? And then pick that Y up and go where? To G. I may have an example of it in here or not. You guys good? Okay. Oh, just harder ones. Let me see. Oh, that's it. We better do these hard ones then. Okay, try these on your own. Okay, everyone get 2x squared plus 4x minus 1 for the first one? Okay, get 4x squared plus 8x plus 2 for the last one, or the next one? Okay, and the last one I threw you a curveball, I put f into f, right? And so your x became your whole thing again, and you distribute, and I got 4x plus 3. Did you get 4x plus 3? And then you put in negative 4. So negative 4 and 4 is negative 16.
Yes.
Plus 3?
Negative 13.
Negative 13.
I forgot to put the negative 4.
Yeah. I did. Originally, I did too. So, questions, guys. Now, I would love to be mean and tell you put G into G, but not for notes. That's for an assignment. Other than that, that's it.